So if my response is categorical, I'm going to be dealing with proportions. Look at the number of levels or the number of collections of data. If there's simply one group of data, that's a single proportion, case 1. 2 groups of data, that is the difference between 2 proportions, that is case 2. That's chapter 6 material. We don't get into this yet. For means, for quantitative responses, we look at a single group, that is a single mean, that's case 3. For 2 groups of information, remember we're not going to look at case 4, the paired data yet. We'll look at that after the midterm sometime. So if we're looking at 2 groups of data and we're looking at means, we're talking about averages in the samples. We're looking at the difference between 2 population means. And that's case 5 in your textbook.
What do you mean by paired again? Paired again?
Yeah, we didn't really talk about this, and this is here because this will show up in chapter 9.
Oh, okay. So
it's just there for completeness. We aren't even going to consider what paired means at this point.
Okay.
This down here is nothing more than the text table that is roughly the equivalent of what's up here. So for categorical variables, we have 1 or 2 proportions. For quantitative variables, we have 1 or 2 population means that we're looking at. These are the symbols for the population parameters. These then are the symbols for the sample statistics that are associated with them. And again, we know that pretty much everything we're going to look at over here, these sample statistics, are all going to have this bell-shaped distribution, that they're going to tend to be centered at the value of the population parameter. Confidence intervals. We should recognize that a confidence interval is the answer to a question about the value of the population parameter. That it always is an estimate plus or minus this quantity here. What do we call this quantity here? It's margin of error. So this quantity is the margin of error that we're going to deal with. So it's estimate plus or minus margin of error. We didn't talk too much about the multiplier and the standard error, but the multiplier is the number of standard errors at the interval will be wide. And the standard error is our best guess at the standard deviation from the population. Actually, it's the standard deviation of the sampling distribution of the statistic that we're looking at. So our estimate is always in the center of the confidence interval. The interval then is symmetric around that. The relationships that we should know, if the confidence increases, so if we increase our confidence level, what should that do to our interval? It's going to increase the width of the interval. So increased confidence means larger margin of error, increased width. Think of the fish net. If you want to be more confident of catching the fish, you want a bigger net. Okay? The other relationship we want to talk about is what will decrease our margin of error? Increasing sample size. So if we increase the amount of information we use to calculate the interval, then we should get a smaller margin of error. Okay? Essentially what that's telling us is if we've got better information about where the fish are, we can use a smaller net to be the same amount confident as we would with larger nets and smaller sample sizes. Okay? Hypothesis testing. We should recognize known alternative hypotheses, be able to write known alternative hypotheses. If I ask you to write down a known alternative hypothesis for a situation, I am going to be very lenient about exactly how you word it, but there's going to be 2 things that I'm going to look for. What's the first thing I'm going to look for in a null and alternative hypothesis?
Case it's not equal.
Which is not equal?
The first case, the null hypothesis.
Null hypothesis will always be an equal.
Oh, yeah, that's right. You're trying to disprove it, though.
The null hypothesis will always be an equals or a same as condition. The alternative hypothesis will always be a not equals or a less than or greater than type condition. It will never contain an equals condition. Okay? What is the other thing that I'm going to look for in statements of null and alternative hypotheses? This is true of both the null and the alternative. What are these statements about? Null and alternative hypotheses are always statements about population parameters. Never include anything about sample values or sample statistics in a hypothesis. I have absolutely no reason to hypothesize about samples, do I? I don't have to guess. The sample's sitting right there in front of me. All I got to do is calculate it. Okay? Hypotheses are always statements about population parameters. Okay, so the two things I'm going to look for is that your statement is about a population parameter and that your statement has an equals condition for a null and does not have an equals condition for an alternative. Okay? You should know the 5 steps of a hypothesis test. We don't have enough to be able to execute the steps, but certainly questions about those 5 steps are perfectly reasonable at this point. You should also recognize that this hypothesis testing is the scientific method. We talked a little bit about the least likely 5% or the least likely what we'll call alpha later on. That's essentially what this is getting at here, is where to find that least likely 5% or that least likely alpha percent for a particular situation. We talked specifically about the case of a not equals condition, and we said the least likely 5% was this 2.5% that's on either side beyond plus or minus 2 standard deviations. Okay? If I have a one-sided test, for example, for a less than, my least likely 5% would be the 5% that occurs strictly to the left. I'm not concerned about the right-hand side at all. If it's a greater than condition, I'm only looking at it to the right, so I'm only looking at this right tail. Okay? So we should recognize the idea, at least, of the test looking for that least likely 5% or so that allows us to reject the null hypothesis. Okay? You should recognize type 1 and type 2 errors. Remember, the type 1 error is you reject the null hypothesis when in fact it's true. That's equivalent to saying that somebody is guilty when in fact they're innocent, if we think of it as a guilty and innocent situation. Type 2 error is essentially the same as letting somebody guilty go. So you have essentially said that you cannot prove the alternative hypothesis when in fact it is true. Okay? So that's the 2 types of error. You should be able to differentiate between those 2. Looking at 2 categorical variables, chapter 6. It would be reasonable to be able to give you a contingency table like this and ask you to answer questions like what is the proportion of those with no tattoos that have ear pierces? So I first reduced myself to those with no tattoos. So I'm looking at this column, and I want to know the proportion that have ear pierces. So I'm going to look at 381 divided by 480. So statements like that where I ask about a subset of the data, which identifies either a row or a column, and then ask you to calculate a proportion within that row or column, you'd then be able to calculate the proportion or the equivalent percentage for that row or column percent.